once again to my channel. All right, so over here we try to demystify some of the LeetCode questions that are available. So today we'll be solving a question tagged as medium, and the title of the question is distinct numbers in each subarray. All right, so now to the question. The question says, given an integer array nums and an integer k, you are asked to construct the array ants of size n minus k plus 1, where the ith ant is the number of distinct numbers in the subarray and some other stuff. Okay, so we are to return the array. So the data structure will be returned over here is an array. Now let's look at the constraint of this problem. All right, so the problem says that the upper bound or the lower bound of this k value is going to be 1. So the k is going to be either 1 or higher. We will not have like a number less than 1. And the upper bound is going to be 100,000. So it's going to be less than or equal to the length of the array, and that one too is going to be less than or equal to the 100,000. So it means the lower bound of k is 1. It ranges from 1 to 100,000. Okay, so now the elements in the array, or like the number of distinct characters we can find in an array, or distinct numbers in the subarray we can find, also ranges from 1 to the 100,000. All right, so we are not going to have like a zero distinct number of distinct characters in our nums or the final array that we return. Delve into the understanding of the question itself. So first of all, let's try to go through this example to see how best we understand the question. All right, so we'll be given an array of integers, and we'll be given a k value, which is a k value which is going to be an integer as well. So what you are supposed to do is to sample a smaller array with k number of items in there, taken from nums in a consecutive order. So when we take this example, when we take the first example, for instance. All right, so let me have this comment over here. All right, so what we are supposed to do after sampling the subarray of k items in there, we are supposed to find a number of distinct items in there. Then we'll kind of like push it into a certain array called ants. Yeah, so that's the task. That's just basically what we are supposed to do, and return the ants after we are done going through all the items in the array. So now let's consider the first. So now let's take the subarray that we'll be dealing with as window. So we're gonna have like window 1, window 2, window 3. So now let's say window 1. So now let's take over here our k value is 3. So let's take the first 3 items from the nums array. So we are going to have something like 1, 2, and 3. So when we look at this subarray that we have like 3 distinct items. So therefore, like our nums array, let's say nums array is going to look something like this. Then we'll have the 3 in there. So now let's look at window 2. This window 1. Let me just copy it over and change it to window 2. Yeah, window 2. So in window 2, because we are supposed to go through the array in a consecutive order, or like taking a contiguous subarray from this big array, right? So we are supposed to shift the array to the right by 1 item. So I'm going to delete 1 and now add the next character to it, or the next number to it, which is 2. So this is 2. Yeah, just to make the number of items equal to k. So right now when we look at it, we have 2 distinct items in here, because 2 and 2 repeat itself, and we have 3. So over here we have 2 distinct items. So here will be 2. Here will be so our nums array will look like 3 and 2. Now let's look at the next window, which is window 3. So for window 3, realize that we are going to delete the previous item. That's shifting it to the right by one number. So we are going to have 3, and the next number that we are going to add is also 2. Yeah, it's also 2. So when we look over here, we still have like the same number of distinct characters, right? So we are going to add the number of distinct characters we find to our nums array. So this thing will continue till we hit the end of our list. Then once we are done, we return our nums array. If I can spell it right. So we're going to return the nums array as given in the example over here. Yeah. All right. So that's basically what you're supposed to do, and this is the example that kind of like explains what you're supposed to do, the requirements. All right. So now, how do we achieve this problem? After going through this example, we'll be employing the sliding window technique to solve this problem. And the reason why we are considering the sliding window is whenever we are dealing with a sub-array problem where we kind of like construct sub-arrays from like a bigger array in a contiguous manner. Yeah, the sliding window kind of gives us the best efficiency to say. So how does this sliding window work? So with this big array, and we are given a k value to construct the sub-array from, right? So our first window, or we'll call like the sub-arrays that we'll construct as windows. So our first window is going to contain the first 3. Then now we kind of like shift we'll shift to the right in the steps of 1. So from here 1 to 3, we'll move to 3 to 3, then 3 to 2, then 2 to 1, in that manner. So that's basically how the sliding window goes. Knowing understanding the question, and also knowing that we'll be using the sliding window technique to solve this problem. Okay, so right now to actually solve the problem, we need to keep track of the number of distinct elements we find in each sub-array that we construct. And in doing this, we would have to have like a data structure that has a very optimized way of adding items to it, retrieving items, and also like removing items from it. And with this information, I believe the dictionary will be the best choice for us. So we are going to use the dictionary to keep track of the number of distinct elements we find in each sub-array. Right. So now let's go to the solution of the question. All right. So first of all, we are going to have a certain dictionary that we are going to keep track of all the distinct items we find. Yeah, a dictionary to keep track of all the items we find. I'm going to call it tracker. That's it, the tracker. Then we're going to have another array called R that's going to keep track of that's similar to the ants over here. So we kind of like push the number of distinct items we find in each sub array to it, and in the end we return it. So in order to use the sliding window, first of all, we'd have to like get the number of distinct items in the first sub array. Yes, so when we take the bigger array that we are given, we'll just slice it into the k, get the first k items, find the number of distinct items in there. Then afterwards, what we are going to do afterwards is we purge or we remove the last item if it has a frequency of 1, a frequency of 0 or lower. We remove it. But if it has a frequency more than that, then we kind of like leave it in there. Yeah. So now let's find the number of distinct elements in our first window. Okay, so this is how we go about it. First of all, we create an array of k items in there. Then we iterate through. If our tracker has that item in there, or if the tracker or object array dictionary has that item in there, we just increment the count. But if it doesn't, then we just assign it to 1. Yeah, so in the end over here, we'd have to push the number of distinct items we find in our first subarray into the array dictionary. And how do you do this? This is how we do it. And paste that here, correct the alignment. So once you find the length of the keys, the length of the keys is going to have like the number of distinct items we have in our first subarray. Then after that, we are going to iterate through the rest of the items in the array. So iterating through the rest of the items. Whoa. So now we iterate through the rest of the items in our array. Yeah, so at each index, right, what we are going to do is if we decrement the previous index, right, so let's say if we decrement the frequency of the previous index by 1, and the value we get is less than or equal to 0, that means that we only have 1 occurrence of it in the list. The reason why we are doing this is when you consider this example over here, right, our first 4 items are 1s. So the first our object is going to have like a key of 1 and a frequency of 4. If you just go ahead to delete the first index of it, because like that's basically what we are trying to do in the sliding window, we just take the first item out and add another item at the end. If we try taking it out, then it means that we are just deleting all these items, right? Because we only have like 4 occurrence of like 1 item. So if you delete it, we are starting afresh in our array. But then if we check to find out that we have how big is the frequency? Is it more than 1? If it is more than 1, then we know that there's another item after that. So in that case, we wouldn't delete it. We'll just move the window to the other side. All right, so now we decrement the count of the first item in our in this iteration or in the nums array. Then after we decrement it, we are going to check first of all before even we delete. Oh no, what's this? Okay, so we are going to check that after we decremented the frequency of the first item in the next subarray, our subarray after the first subarray that we did up here, after we decremented the first value, right, the frequency, is the frequency less than or equal to 0? If it is less than or equal to 0, then we only have 1 occurrence of it. Then we want to kind of like remove it in our tracker dictionary. So if the frequency is 1, yeah, so we remove it. If it is not 1, we leave it there because of the explanation I made over here. Then after doing that, after taking care of the first item, the next thing we do is we look at the current item with the index that we are currently on. So the current item in our nums array, if that one is already, if there's an occurrence of that key in there, we increment the value, the frequency. But if there's no occurrence, then we assign 1 to it. If it doesn't occur in our tracker dictionary, then we kind of like assign 1 to it. Then in the end, we do the same thing. We add the number of distinct items we find. The number of distinct items. Then we return the number of distinct. We return the array after everything. So return R. So let's try running our code to see. All right, so we are passing all our test cases. Let's submit. All right, so the code is still passing. Let's take a look at the runtime analysis of our code. So the for loop over here is going to proceed in O of k time, because we have like k items that we are iterating through. So for dictionary update and dictionary gets, they all proceed in constant time, so O of 1. Then over here, getting the length of the number of distinct items in the sub array that we have, or the dictionary that we have. The worst case is just like looking at all the items in the list, so it's going to proceed at O of k, right? Then for this loop, because we are not looping, we are not going through each and every item in nums, but we are slicing it. We are starting from k, so the runtime over here is going to be O of n minus k. Dictionary get, dictionary update, all of them proceed in constant time, O of 1. Then same thing applies to over here, so that one is O of k. So finally, runtime is going to be O of k, that's for the upper one. Then I think plus O of k as well, plus O of k, O of k. Then we have O of n minus k, that's for this for loop, then multiplied by the O of 1s that we have over here. Then the O of k we have for updating or finding the length of the distinct characters we have. So all this is approximately going to give us O of n. Yeah, so that's the runtime analysis.